Good day, everyone. We are now moving to our next topic, which is plate tectonics. Please do not forget to, um, you can actually write your questions in the comment section, or perhaps you may message me personally or sa group chat natin if we have clarifications or questions regarding the lesson. Continental Drift, an idea before its time. By the way, we have here the person of Wegener's continental drift hypothesis stated that the continents had once been joined to form a single supercontinent. This was the idea of Wegener's because, according to him, and of course, he believed that these present continent they are not arranged like that now in the past. He actually believed that at some point before, these continents are actually they actually drifted to this present arrangement, no? And then of course another assumption of Wegener is that the seven continents of seven major continents now they were pasted or puzzled as one, no? And he called it as a supercontinent. Wegener proposed that the supercontinent Pangaea began to break apart 200 million years ago and form the present land masses. Because of the readings of Wegener's, actually, because of his idea and then idea on those readings, parang napagtanto niya based on some evidences, although the evidences are somewhat vague and ambiguous. Um, that's the reason why it triggers now the concept of continental drift, no hypothesis of beginners. But then again, marami pa itong problema, hindi pa talaga ito na-realize, no? So this is not the breaking up of Pangaea according to Wegener's hypothesis, no? So we have here our supercontinent Pangaea. After some time, they drift apart up to this present arrangement. No? We will go back to the evidences that Wegener's proposed, and let's try to look at if the argument of Wegener's are true, of course, or not. Now let's try to look at evidences. Of course, the first one is the continental puzzle. If you're to look at our continent, no, if you're going to go back, I don't know if you have example here, no, this one. Let's just run through the evidences. We have the continental puzzle. We have matching fossils, no, and then we have the rock types and structures. We also have here the ancient climates. Now let's try to look at this particular example. I don't know if we still have it here. Okay, there's one. The first evidence talks about the continental puzzle. And that is actually true. If we're going to look at the structure of the continent and then kung itatagpi mo sila, you would notice that at some point para siyang puzzle-like, no? It can be fit into another. But then again, please take note that especially the edge part, no, the outer side of our continents, they are not perfect now. Of course, they were eroded. Kasi nga, because siguro natabunan ng tubig at some point, no? But if we're going to look at here, like for example, North America and then the side of North America and South America, together with Europe and Africa, if we're going to paste them like a puzzle, you would notice that they actually fit. No? And that is one, I think this one is the strongest argument. I do not know if it is really true, but this is the strongest argument or evidence of Wegener. Okay. The second one is the fossil. Now, according to here, is that we have matching fossils. Fossil evidence for continental drift includes several fossil organisms found on different land masses. Actually, na-notice ni while reading some books, Wegener's here notice that there are fossils, no, there are fossils, or there are even organisms, na mga fossils na mga organisms they could actually find here in Africa and of course in North America. There are organisms, fossils, no, that you can find in South America and then on the other side, which is here Africa. Now, please take note that we have here the idea in biology that in every organism, no, yung mga organisms na to, if that is an animal or plants, they could actually thrive in an environment, in a specific type of environment. No, meaning to say, by the time they will be subjected to this particular environment, they would conform to the environment. So you get the idea. By the time they will adapt to the changes of that environment, perhaps they will change, and of course, hindi na siya the same. But according to the evidences presented, no, according to the readings of Wegeners, there are fossils that you can found in Africa and South America. There are fossils that you can found in the other continent to the other continent. So that's the question. So the question now is paano ba nag-travel itong mga plants, no? Paano ba nag-travel itong mga animals where they were ano ba sila? Are they flying? Are they and so on. Okay? So that's another idea. The other one is the rock types and structures. Rock evidence for continental exists in the form of several mountain that end at belts that end at one coastline, only to reappear on a landmass across the ocean. The same, this one, the matching mountain ranges, you would notice na meron ditong Appalachian Mountains, and then meron siyang uh, specific specific rock type and structure, and then only to notice that if you're going to look at the British Isles and then the Caledonian mountains, this same um, what you call this rock structures, no. So meaning to say, you could actually notice that at this point, perhaps, no, one of our argument now is this particular part here and this part is isa na sila long before. Okay? Okay, because again, whatever the components of a particular continent, it is actually dictated by the environment, no? So most likely there could be chances na wala jud siya, or no, there could be no chances na meron talagang the same structure ang other continent to another continent because again the environment is very different. But now the argument is that they have the same rock structures on this part, no? And this edge part of your North America, the Appalachian Mountains, and then taking notice about here in British Isles, and of course, we also have here in the Caledonian Mountains, they have the same, what you call this, the same rock types and structures. Okay, so again, the argument now, or our assumption is perhaps this particular place here and ito, isa lang na sila sa una. Okay, so this is now the assumption on this side. The other one is the ancient climates. You would notice here, no? As Antarctica in this side, mora ni siya ang snow diri dapita, no? Mag-snow ni siya. And because of the drifting now, you could actually see that at the bottom line, at the bottom part of South America, the bottom part of Africa, and the bottom part of India and Australia, they have this glacier, no, on their part. It is because since South America is just one place, ngano kang wala pod walay glacier sa tibok South America. Nganong walay tibok ice or glacier sa tibok Africa. Now, well, in fact, that again, South America has a different climatic factors and environmental factors with Africa and the other continent, no? Bakit ito ang merong tinatawag natin na glacier or ice? So I mean to say at some point, perhaps South America is part of Antarctica, Africa is part of Antarctica, and India is part of Antarctica. That's the assumption. Okay. Rejecting the hypothesis. Now, this is now the part wherein I told you that the idea of Wegener, by the time he proposed it, it was actually not a very successful idea or hypothesis. No, there are a lot of people who rejected the hypothesis. It is because perhaps the idea of Wegener or the hypothesis is very ambiguous and very vague. Very limited ang explanation ni Wegener. Why do you think that these large masses of land moved? Ano kaya yung rason bakit yung particular big area, like for example, very big Africa, nag-move siya? Sino ang nag-move ng continent na yan? What are the reasons why these particular continents moved? Correct? So Wegener could not provide an explanation of exactly what made the continents move. This is now the time that geologists and geologists ba, mga physics enthusiasts, no, our physicists, they actually ask what is now the physics behind the idea of Wegener? They cannot explain it through physics, therefore, they rejected the hypothesis. Even the biology part, the chemistry people, they really don't believe or they can explain, coming from their existing knowledge, why these continents move. So that is why, since by the time na merong problema sa evidences, they ask Wegener, why do you think these continents move? And then now that now that Wegener could not provide a very exact and very concise or very not really exact of the technical explanation on how these continents move, that's the time that they rejected the hypothesis. News technology, a new technology, sorry, new technology lead to findings which then lead to a new theory called plate tectonics. Because of the idea of Wegener, no? Meron tayong there is a new emergence of theory which we call it plate tectonics. To nangyari. It is because I think I don't know if it could okay, so hindi na discuss dito. There is, I do not know really know if the person is, if the person was a what you call this, a captain, no? A captain. And then because of some technology, ang ginawa niya, gusto niyang malaman yung depth ng ocean. No, gusto niyang malaman yung depth of ocean. I think this particular technology uses sonar, no? They use sonar, no, to identify kung gaano kalalim yung ocean. And because of that sonar, because of that idea, because of that, they actually map the ocean floor. No, they notice, and of course they knew the picture now of our ocean floor, that our ocean floor is not actually flat. No, so dagan di kayo siya yung mga formation. This is now one of the breakthrough when it comes to the concept of geology. And this is now the reason why we have our new theory that emerged, no, which is what we call plate tectonics because of that. So, Earth major rules. According to the plate tectonics theory, the uppermost mantle, along with the overlying crust, behaves as a strong, rigid layer. This layer is known as the lithosphere. So we call it lithosphere. That is the what you call this the solid part of our Earth. A plate is one of numerous rigid sections of the lithosphere that move as a unit over the material of the asthenosphere. Asthenosphere, by the way, is the region between your mantle and your crust. No, that is actually the weakest region between mantle and crust. So your asthenosphere, since that is the weakest region, therefore then, ito yung mayroong big role when it comes to the movement of your crust and mantle. Meron siyang big role when it comes to the movement of your plates. No? That is asthenosphere. Again, asthenosphere is the weakest region between your crust and then your mantle. Okay, so we have here sa concept natin sa plate tectonics, we have here three types of plate boundaries. We have divergent boundaries, we have convergent boundaries, and transform fault boundaries. When we say divergent boundaries, when we say meaning two, also called spreading centers, no? So meaning to say we have two plates that are separating or they are spreading. So divergent boundaries are the place where two plates move apart. The second one is convergent boundaries, formed where two plates move together, nag-converge, mula silang nagbangga, no? They collided, okay? And then transform fault boundaries are margins where two plates grind past each other without the production or destruction of the lithosphere. So ang ginawa lang sa transfer fault boundaries dito, nag-slide lang siya with each other. Okay? Slide on the opposite side. Okay, so that is what we call our transform fault boundaries. I think we have our pictures here. Yes, this is our divergent boundary. Take note that is the spreading of two plates. And then sa ating convergent boundary children, you would notice that there is a collision of two plates. No, we have here the oceanic plates here, and then the other plate. Okay, and then if you're going to notice here, our transferred fault boundary, nag-slide lang siya with each other. No, nag-slide lang siya. That is our transform fault boundary. Okay, divergent boundaries. So actions at plate boundaries. Let's try to look at here what is really the mechanism of your divergent boundaries. Again, divergent boundary that is the spreading of two plates. Oceanic ridges and seafloor spreading. Because again of the new technology, there are people now who actually map our ocean floor, and because of that mapping, they notice that our ocean has ridges. And then of course, meron tayong concept of seafloor spreading. So what are oceanic ridges? Oceanic ridges are continuous elevated zones on the floor of all major ocean basins. The rifts at the crest of ridges represent divergent plate boundaries. Para siyang nabibiyak, no? When we say ridges, oceanic ridges, no, parang na-separate. Okay. Rift valleys are deep faulted structures found along the axis of divergent plate boundaries. They can develop on the seafloor or on land. And then when we say seafloor spreading produces new oceanic lithosphere. I think we do have pictures here, yes. So we have here our Rift Valley. Take note on the upper side, on the upper picture photo, meron tayong spreading of plates, okay? And then on this side, we have our, what we call this, the Rift Valley. Yung Rift Valley parang siyang the resulting biak of your divergent boundary. Okay? And then right after some time, pwede siyang malagyan ng tubig. We call it linear sea here. And then, nidako siya, we have here our continental crust. No? They are now pulling on the opposite side. And then on the ocean floor, you would notice what we call the oceanic ridge. Parang nabibiyak. Okay? Yan. So continental rifts, when spreading centers develop within a continent, the landmass may split into two or smaller segments, forming a rift. Again, yung rift para siyang canal. Okay? So that is one. Okay, yan. This is an example of a rift valley this is from East African. Okay? East African Rift Valley. Okay. Next is convergent boundaries. A subduction zone occurs when one oceanic plate is forced down into the mantle beneath a second plate. Okay, let's try to look at now what is the subduction zone. No? Okay, so we actually have, I think we have three types or kinds of convergent boundaries. We have oceanic continental, we have oceanic, and we also have here continental. Again, we have three types of convergent boundaries. We have oceanic continental, we have continental. We also have oceanic. Okay. For the first one, we have here oceanic continental, meaning to say plates na nanggaling sa ocean and then plates na nanggaling sa land. That's we call it in the layman's term, no? So denser oceanic slab sinks into the asthenosphere. So sino daw yung subduct, no? Okay? That is actually a denser oceanic slab. So because of the materials, actually, your oceanic plates, no? Your oceanic plates and then your continental plates, they have different components, no? Um, if you are trying to look at here, oceanic plates, it actually submerged, no, sa ocean. Therefore, there are a lot of minerals sa ocean. Okay, because of those minerals, it of course it is actually dissolved in your plates or in your soil whatsoever in a slab, making it as very dense. Now, yung idea natin dito is when we say dense, let's try to equate that for the purpose of discussion. Let's equate the word dense or denser as mas mabigat. Okay? Since oceanic plates they are denser compared to continental plates, therefore ang magsabdak ang bababa ngayon na plate will be the oceanic. Okay, so denser oceanic slab sinks into the asthenosphere. Remember, asthenosphere, the weakest region, no, between your mantle and then your crust. Pockets of magma develop and rise. And then, if there is an oceanic continental, ang ma-form, no, the product of the oceanic and continental convergent boundary would be a continental volcanic arc. Okay, ibig sabihin, by the time na magbangga ang imong karong oceanic plate and then your continental plate, the resulting output now, or the output of that convergence, is what we call the continental volcanic arc. So, merong magiging volcano, no? So, continental volcanic arcs form in part by volcanic activity caused by the subduction of oceanic lithosphere beneath a continent. Examples of oceanic continental includes Andes, Cascades, and Sierra Nevadas. Actually, they we actually we are very what do you call this, curious kung yung volcano or mountain ba natin, will they be, mawawala ba sila? Or at some point, are there times or meron bang time na walang maproproduce na volcano or mountain? No. I think the answer is, as of the moment, no. There could be no chances, no? Walang chance na walang magiging production or result of volcano or mountain. It is because as long as our plates are moving, they could produce either a volcano or a mountain, okay, or a valley or whatsoever, okay, as long as these plates are moving. Okay, so continental volcanic arcs are form, and the last bullet enumerated as the examples of oceanic continental. Actually, there are a lot of questions if Japan is an example of oceanic and continental. We'll know later if Japan, Hawaii, Papua New Guinea, saan kaya sila example? Paano kaya sila na nag-emerge, no? Okay. So this is now the picture of your oceanic continental convergent boundary. For the purpose of discussion, let's try to look at the picture. Ito yung sinabi kong subducting oceanic lithosphere, and this is asthenosphere. Okay? And when we say continental plate or continental crust, ito yung crust na nandito sa side natin na walang tubig. Okay. So in layman's term, sa yuta, literally sa yuta or sa soil, sa land, okay? Walang tubig. When we say oceanic crust, that is the crust beneath or below your ocean. Okay? Since our crust now is below our ocean, I told you that meron talagang difference between the components of these two crusts. The main difference now is the chemical component. Now, what makes this oceanic crust to subduct? So ano yung rason bakit yung oceanic crust natin siya yung bumaba? The main reason of that is because the chemicals are very heavy for that particular crust to lift up, no? To lift. So ang nangyari, since maraming minerals dito, and then siguro yung minerals dito, they are very dense, napakabigat, and it makes your oceanic crust denser. Since your oceanic crust is denser compared to the other, so siya ang musabdan. Please take note that according to literature, the angle of subduction is only 45 degrees. No? 45 degree lang yun na siya ang iyang subduction. Okay. So, sir, is that constant? I don't know if it is still constant up until now, because according to my reading, according to that particular literature, the subduction zone is 45 degree. So 45 siya dili napita. Okay? And of course, according to our idea on oceanic continental convergent boundary, by the time they will be converged, ang ma-form nato is what we call the continental volcanic arc. So, mo ni iyang product. No? Okay. So, sir, lahat ba talaga mayroong product? Yes. Okay? So, between oceanic continental, the product is the continental volcanic arc. And then, of course, that this is very obvious that by the time magbangga ang duha ka crusts, naagid tayo murag kanal nga ma-form, and we call it trench. Okay, our Marianas Trench, that is the reason why we have our Marianas Trench. It is because of the convergence of two plates. Okay? So ang result yun ana basically is the trench. So atong Marianas Trench, siya yung pinakamalalim na trench natin. Okay? Next convergent boundary we have is the oceanic, meaning to say this is now the convergence of two oceanic plates. So two oceanic slabs converge and one descends beneath the other. So dapat meron talagang isa na mag-descend. Again, our idea kung paano siya mag-descend because how it descends, it is because of the content of your crust, no? So kung sino yung denser, siya yung mag-descend. So this kind of boundary often forms volcanoes on the ocean floor. So ang resulta daw ng oceanic no ang pag-converge no ng dalawang oceanic plates ay the formation of volcanoes on the ocean floor. That is why we have volcanoes beneath the ocean. Okay, volcanic island arcs form as volcanoes emerge from the sea. So, ito yung form niya volcanic island arcs. By the way, our volcanic island arcs, we have, I think there are two, no? The other one submerged, no? And then some of the time, merong time will come that that particular volcano will actually sprout, no? Sa ato ang tubig or sa dagat. So examples include the Aleutian, no, the Mariana, and the Tonga Islands. So they were examples of volcanic island arcs, the result of the oceanic convergent boundary. Okay, so ito yung mangyayari. We have here two oceanic crusts here. So they were converged, and then of course nandito na naman yung crust natin, trench, sorry, and then the result now would be the volcanic island arc. Okay. The third one is the continental, wherein ang Utah daw, in layman's term. When subducting plates contain continental material, two continents collide. This kind of boundary can produce new mountain ranges such as the Himalayas. So, ang resulta naman ng continental are mountain ranges. Very good example would be your Himalayas. So, balikan lang natin. For oceanic and continental, it will form continental volcanic arcs. But for oceanic and oceanic, it will form a it will form an oceanic volcanic arc. Okay? And then for the continental, it will form mountain ranges. Okay. So this is now the photo or picture of your continental convergent. The same with the case, no? Kung sino yung denser na material, it will descend. Okay. So most likely wala talagang magpaparaya dito. That is why since wala gaano magpaparaya, wala talagang mag-descend, that is why ang the resulting would be pasaka, no? Mo-up yan, dalawang crust, and then the other crust mo ana siya. That is why you can form mountain ranges. Okay. Sige. Okay. So collision of India and Asia. Ayan. So we have here our Himalayas. We have India here. And then we have Tibetan Plateau. We have India. This is an example, I think, of India. Okay. This one, India. And then we have here Tibet. Okay. Next would be your transform fault boundaries. At a transform fault boundary, plates grind past each other without destroying the lithosphere. Transform faults most join two segments of a mid-ocean ridge. At the same time, at the time of formation, they roughly parallel the direction of plate movement. They aid the movement of oceanic crustal material. For us really to understand, let's try to look at this picture. This is now the picture of your transform fault boundary. Please take note na walang destruction perhaps na mangyayari of your plates. It's just because they just move, no? They grind on each other lang. The bad side here is that meron talagang another formation. For example, this is actually an example of a rift, no? No? Kini siya, rift nor a ridge. And then because the other side is moving and then the other side is moving, natunga siya, no? The other side, yung rift naabot siya dito sa pikas, and then the other side nandito na naman siya. There was a joke. I think I don't know if it was a joke, but it actually happened during an earthquake, and the movement of the plate is more on transform fault. So yung bahay niya, merong sa loob ng bahay niya, meron dong fault line. Since yun yung fault line, mean to say, yan yung tendency na mag-originate yung pag-move ng plate, no? Parang yung slice ng dalawang plates natin or dalawang slice ng cakes. By the time nag-move siya because of an earthquake, the other side nag-move siya pasaka, then the other side ni-move siya paubos. No, nag-slide siya. So the half of the balay is nandun na sa kabilang barangay, the half of the balay napod siya sa pikas opposite nga barangay. Okay? So this is now the idea of your transform fault boundary. Okay. Next is the idea of paleomagnetism. Paleomagnetism, of course, we will be talking here about the mechanism of magnet or magnetism or magnetization. So evidence for plate tectonics. So we have here the mechanism on testing our plate tectonics by the idea of paleomagnetism. Paleomagnetism is the natural remnant magnetism in rock bodies. This permanent magnetization acquired by rock can be used to determine the location of the magnetic poles at the time the rock became magnetized. So we have two polymagnetism. We have normal polarity and we also have here the reverse polarity. When we say normal polarity, when rocks show the same magnetism as the present magnetism field, and we call it normal polarity. But when rocks show the opposite magnetism as the present as the pre, as the present magnetism field, we call it reverse polarity. Okay, so that is now the idea of paleomagnetism. This paleomagnetism, they believe now, or geologists believe that we have our natural remnant of magnetisms in our different types of rock or in our rock bodies. Okay, and because of this, malalaman talaga natin yung mga magnetic poles, no, at the time the rock became magnetized. So like for example, we have here our normal magnetic field. Our magnetic field 1.2 million years ago, normal. And then, paabot diri dapita kay ni-reverse siya, and then normal na sad. Okay? So that is the polymagnetism preserved in lava flows. Okay. Evidence for plate tectonics, the discovery of strips of alternating polarity which lie as mirror images across the ocean ridges is among the strongest evidence of seafloor spreading. Because of the opposite directions or because of the changing direction of the polarity of our polymagnetism, nakaingon karon ang mga geologists that really plates are moving. No, at some point perhaps if this is the direction of the magnetism polarity or the polarity of your magnet, perhaps this particular rocks here will be pulling padung dito and then on the other side. Okay, so we need to say really our plates are really moving. No, they are spreading perhaps. Okay. Polarity of the ocean crust, the period of normal magnetism, period of reverse magnetism, try to look at it, no? And then period of normal magnetism. Okay, anyway, next, earthquake patterns. Scientists found a close link between deep focus earthquakes and ocean trenches. The absence of deep focus earthquakes along the oceanic ridge system was shown to be consistent with a new theory, which is the plate tectonics, no? The plate tectonic theory. Okay. Anyway, we will be having a separate discussion on earthquake. I think next module would be earthquake, so we'll be discussing it more. Next, we have another evidence for plate tectonics, the ocean drilling. The data on the edges of seafloor sediment confirm what the seafloor spreading hypothesis predicted. No? The youngest oceanic crust is at the ridge crest and the oldest oceanic crust is at the continental margin. Kasi nga mag-spread man siya. So the youngest oceanic crest nasa ridge gid crest yung sa biak mismo, no? Sa biak mismo. And then the oldest oceanic crust is at the continental margin, nasa pinakagilid. Okay? So let's try to look at a picture here dito, no? Di ba, they will be separating. So meaning to say the youngest oceanic nandito makikita. Young man, okay? And then the oldest nandito sa continental margin. Okay? Kasi matagal na nag-move. Okay. Next, hotspots. A hotspot is a concentration of heat in the mantle capable of producing magma, which rises to Earth's surface. The Pacific plate moves over a hotspot, producing the Hawaiian Islands. So remember that the Pacific Ocean or the Pacific plate, that is actually the region of what we call the Pacific Ring of Fire. No, it is termed as it is labeled as part of the Pacific Ring of Fire. It is because that particular part is actually a hotspot. No, meaning to say hotspot, there is a lot of concentration of heat of the mantle which is capable of producing magma. And then the Pacific plate moves over hotspot, producing now your Hawaiian Islands. Hotspot evidence supports that the plates move over the Earth's surface. This one, we have, I don't know I don't know if I will pronounce it right, Kayawe. Okay. And then of course that spot Hawaii. Okay. Causes of plate motion. Scientists generally agree that convection occurring in the mantle is a basic driving force for plate movement. Of course, we already know what is convection, no? And convection now is the because of the differences of the temperature, mo siyang mag-form of or cyclical. Okay? The so siya, the hot material, no, or material having a high temperature will rise, and then pag mag-cool down siya, bababa na naman, and then pag mainitan, it will tend to rise, and then sa taas, it will cool down, it cools down, bababa na naman siya. Sa baba, nainitan siya, so it will tend to rise. So that is actually what we call convective flow. Your convection now or convective flow is one of the idea or the basic driving force of your plate movement. Siya yung isa sa mga tinaguriang oldest na what you call this driving force or mechanism of what causes your plate to move, no? That is because of convective flow. Convective flow is the motion of matter resulting from changes in temperature. Okay. Another idea aside from convective flow, we have here the idea of the slab pull and ridge push. Okay. Slab pull is a mechanism that contributes to plate motion in which cool, dense oceanic crust sinks into the mantle and pulls the trailing lithosphere along. It is thought to be the primary downward arm of convective flow in the mantle. Ang slab pull lang, the mechanism that contributes to plate motion in which the cool, no, and then dense oceanic crust bumaba. Diba? Slab pool, nibaba siya. That is the concept of slab pool. And then mura siya turn around, nituyok. Okay. Of course, the cooler and then the denser oceanic crust will go down. And then pagbaba niya, of course, sa ilalim, napakainit, naiinitan siya, it will go up na naman. Okay? And then another, pag pupunta siya sa taas, it will cool down. And then of course, it will be denser, bababa na naman siya. That is the concept of the slab pool. The same concept din siya of what we call a convective flow in the mantle. Okay, so that is slab pool. I hope you could imagine that. Anyway, I will be posting video of these mechanism para naman mas makita ninyo yung idea. And of course, we have here the idea of ridge push causes oceanic lithosphere to slide down the sides of the oceanic ridge under the pull of gravity. It may contribute to plate motion. So anong nangyari, this is now, it causes the oceanic lithosphere. Again, this is the lithosphere na naman na nasa sa ocean na part, so basa, to slide down the sides of the oceanic ridge. So saan siya pupunta? Doon sa oceanic ridge. Okay? Under the pull of gravity. So ang mangyayari, children, remember, di ba, mura siyang ma-open because mura siyang merong kanal. Okay? So ang mangyayari, yung oceanic lithosphere will slide down, pababa na naman siya sa ilalim. So para siyang babalik, no? Doon sa parang nabiag. Okay. So because of the pull of gravity, it may contribute to plate motion again. We call it ridge push. Another cause of plate motion, we have here the mantle convection. Mantle plumes are masses of hotter than normal mantle material that ascend toward the surface, where they may lead to igneous activity. Remember that the hotter mantle, it will tend, because of it's actually part of the ano ba yan? Part of the nature wherein yung napakainit, no? Yung any materials that will be heated or any materials that are hotter will actually rise, no? So kaya nga sinabi dito, masses of hotter than normal mantle material that ascend, pag sinasabing ascend, nisaka siya toward the surface because of the init or the high temperature, where they may lead to igneous activity. The unequal distribution of heat within Earth causes the thermal convection in the mantle that ultimately drives plate motion. Remember, we have our whole Earth here, and of course, we cannot assume that we have a very equal distribution of heat. Wala naman. No? So, meaning to say, by that idea, we could actually see that there is really unequal distribution of heat within Earth. No? Because of that unequal distribution of heat, mo nang naatay always gitawag nato nga thermal convection. Because of that thermal convection in the mantle, time to time materials that yung nasa loob ng earth will ascend, and then materials na nasa taas na naman will go down, will descend, no? So normally that is what we call thermal convection. Again, because though of the unequal distribution of heat. So those are one of the causes of your plate motion. Okay, so I hope that is clear. So let's try to review the driving forces of your plate motion. The first one is the ridge push. Ito yung sinasabi nating ridge push, no? So remember, it will be separated, but at some point, babalik siya sa, bababa siya ulit because of the power of gravity. Okay, and then we also have here the mantle convection. Try to look at here, napakainit dito sa taas. So there are materials that will go up, will ascend, and then right after some time it will go down kasi nga it cools down, and so on. Okay, and then sa slab pool, the same. This particular material here, the oceanic crust, is very cool, cool, and of course denser, therefore bababa siya. Okay, bababa siya diri, old cold dense lab. Okay. And then of course, the ridge slide, mag-slide siya dito. Okay, this is now the mantle convection models. Please take note, again, our assumption here that the Earth don't have equal distribution of heat. Because of the unequal distribution of heat, we do have thermal convection. Okay, so mo ni siya ang mga thermal convections niya, ni Saka rising plum, no? And then bababa na naman siya, napainita na pod, musaka na pod siya. That is your hot spot, no? And so on. I hope you get it.